We're going to take a look at systems of equations and how to solve them using the elimination method. So systems of equations is whenever we have two equations that have two variables or more. So we could have three equations, three variables. If we look at this first example here, we have negative 5x plus 10y equals negative 15, and negative 7x minus 10y equals 27. If we notice, the middle column there, the y values, are the same value except they have opposite signs. What this means is we can eliminate the y variable from the equations simply by adding the two equations together. When I do this, negative 5x plus negative 7x will give me negative 12x. The positive 10y and negative 10y added together cancel out, and negative 15 plus 27 is positive 12. Now we have a single equation with one variable, really easy to solve, so we're going to divide both sides by negative 12, and that gives us x is equal to negative 1. Now to figure out the y variable, we're going to take that negative 1 and we're going to plug it back into either of the first two equations in for x. When we do that, let's say we use the first equation, that would be negative 5 times negative 1, which turns into positive 5. So our equation up top would be 5 plus 10y equals negative 15. And we can solve from there to get y, or y equals negative 2. To write our answer, because it's an xy, we write it as the ordered pair, negative 1, negative 2. Now what happens if the two variables are not opposite of each other? So in this case, we notice that our y values again have the same value, but the signs are exactly the same. Well, we treat it very similar to how we treated the first method, but instead of adding the two equations together, we're going to subtract the bottom equation from the top equation. That will still eliminate that variable in the middle. So 7x minus 5x is 2x, 4y minus 4y cancels out, and 26 minus 22 is 4. Again, we are down to a single equation, one variable, and we can solve. We get x equals 2. Taking that 2, we can plug it back into either of the original equations for x and solve to get our y variable, which in this case will give us y equals 3. Writing it as an ordered pair, 2, 3. Now this time around, the equation looks a little different. When I look, the numbers are not the same. They're different. I have 1y for the first equation, and I have negative 7y for the second equation. So I need to do something in order to make the numbers the same. Because that first equation, the variable is just 1, or the coefficient is 1, we're going to multiply it by whatever the coefficient of the second equation is. So I see that second equation is 7, so we're going to multiply everything in the first equation by 7, which will turn the equation from 10x plus y equals 8 into 70x plus 7y equals 56. Now, as we notice, the numbers are the same in the middle, and they have opposite signs, so we're just going to add the two equations together. 70x plus negative 2x will give me 68x. 7y plus negative 7y cancel, and 56 plus 12 is 68. Solving for x, we get x is 1. Now we can take that x equals 1 and plug it back into either of the first two equations and solve for y. And we will get y equals negative 2. Writing it as an ordered pair, we have 1, negative 2 as our answer. The final case that we could have is, again, we notice our middle column is not the same. However, this time, both of them have a number. Neither one of them is just 1, so I can't just multiply by the opposite and get rid of it. So I need to do something to both equations. So what I'm going to do is I'm going to take that first equation, and I'm going to multiply it by whatever the coefficient in front of the y is. So I'm going to take that whole first equation and multiply it by 4. Similarly, the second equation, I'm going to multiply by the coefficient of the y in the first equation. So I'm going to multiply the entire second equation by 5. When I multiply the first equation by 4, it turns into negative 24x minus 20y equals negative 32. And now multiplying that second equation by 5, I will have negative 35x minus 20y equals negative 120. The middle column is the same, and both of them are negative, which means we are going to subtract the two equations from each other. So negative 24x minus negative 35x. The minus negative turns that into a positive, so we're going to have negative 24x plus 35x, which will give me 11x. The 20y's will cancel out, and negative 32 minus a negative makes that a plus, so negative 32 plus 120 is 88. Dividing both sides by 11 will give us x equals 8. And now we take that 8 and plug it back into either of the first two equations for x and solve for y. When we do that, we will get y equals negative 8. And remembering to write our answer as the ordered pair, 8, negative 8.